Hello everyone, my name is Natalia and I'm a software engineer at Equal Experts. And since the beginning of my career, I was curious how deep the security rabbit holes can go.
Well, I think probably several of you know me. I'm Giovanni. I'm not a security expert, I'm a developer. I have a strong interest in security and my laptop locked down, so sorry, I'll unlock it first. And today we'll be talking about what we can do as developers in terms of improving the security of our systems.
We are concerned about the security, and as we have been working in consultancies, we saw quite a lot of teams that do not take security into account. And we're not security experts, however, we don't have to be them in order to make our software better and more secure. Yeah, and as Giovanni said, today we would like to discuss what we can do as developers to make our applications better.
Yeah, you'll see that there is quite an overlap with today's keynote. We didn't know that, but was very useful. And maybe we'll try to be just as good as the keynote, but I cannot promise anything, okay? So if the laptop responds, sorry for the problems. I move from here. Okay.
Now we can go further. So nowadays, we build indeed quite extraordinary systems. We put a lot of effort to make them live. We put a lot of effort to make them robust, fast, user-friendly. However, we tend to forget about quite important aspects, security. And it can have a great impact on us. It can have impact on deadlines because it takes time to find the error, to fix it. It can have a legal impact, especially nowadays, after some laws came out. It can have a cost impact because it takes money for resources and developers' time. It have a reputational damage because nobody wants to appear in a newsletter with a bad title or even lose customers because of a security breach. And people...
Oh, sorry. Yes.
And people think that it is about the big companies or banks that contains a lot of sensitive data, involves money. However, not just. It's about all applications. For example, a flower shop. What can go wrong with a flower shop? But think if it would contain your data. Your name, your surname, your number, your delivery address. I would particularly don't want to be called again and again by phishing with a car accident because somewhere my phone have been leaked from the database. And as well, it's not just about the hackers who are sitting somewhere and trying to hack your application with the internet, because internal threats are even more risky than external ones. And we try to defend against all bad guys, no matter where they are.
And also, there are aspects nowadays, you know, with the Internet of Things, or with things like Alexa, so voice interface, Alexa, Google Home, that are posing new challenges. So we can give you some examples. Maybe something that you know from the news, I think was in 2016, when there was a denial of service attack launched by light bulbs that were connected to the internet. The problem was all the light bulbs had exactly the same security certificate. Somebody figured that out and used them for a distributed denial of service attack. Or Alexa, for example, and Google Home at Zuhlke, what we did also was some prototype for managing banking applications using the voice interface. Now imagine the security implications there. If you have to find a way to actually protect the data, because if all you have to do is like, Alexa, open up my big bank app, and Alexa responds yes, and then what is my balance, tells you the balance, and say pay so much money to this other account. Okay, unless you have a way of protecting this, anybody that comes to your place, maybe a thief, says, you know what, there is an Alexa there, let's try this. Yeah, will be easier to transfer money. Yeah, and the same with Google Home. Or you see a shower head here, And there is a reason. This is a IoT-connected showerhead. Now, you laugh. There is a use case for this that is not only showerheads for geeks that really want to hack them in their home. Is that one of our customers actually produces these things because they build bathrooms for hospitals and big places, big companies. So you can imagine a big hospital has lots of these things, and they need to manage them. You know, how do they know that something is broken and send somebody there to fix it? Yeah, you cannot have people wandering around all the time. Yeah, but again, there are some interesting security implications that sometimes are not immediately visible, because when we were speaking with these people, they told us, you know, what we do with these things is also we need to disinfect them. In order to achieve that, we activate a hot water flush in the shower. So at the moment, it's done with a person who goes to the room, checks, there is anybody there? No? Activate that. We want to do this remotely. Say, okay, that's interesting, because you actually cannot rely only on the showerhead. You need to rely on some other sensors. You need, you know, replication. You need backups. Basically, you need to check that nobody's in the bathroom. You cannot do with this thing, yeah, which is one aspect. Then there is another security aspect, that is, if it is easily hackable. Imagine in an hospital when they have people of interest. You know those kind of guys that make you offers that you couldn't possibly refuse, but they don't feel well and they're in an hospital, maybe with the police looking at them, and they have to take a shower. And there is some people that are afraid of them speaking up. They can hack the system and give the person a beautiful hot water flush and kill the person. You see, there are these kind of implications that when you first think of using these things, you just don't think about this potential, yeah? Okay, so there are all these aspects that we need to somehow manage nowadays. And also, there is another interesting aspect of security. Security is an aspect of reliability, yeah, of the system that most customers expect and all customers want. This is an interesting quote, because how many times you have been asking your system to keep security in mind when you produce the system? Yeah? Well, in how many applications actually you have security requirements that are stated explicitly by the customers? My experience is very, very few. Probably the last time was when I was actually working on an authentication system, for obvious reasons, yeah? But in general, they don't ask you about the requirement, but they expect it to be there, okay? Which makes the problem slightly more complicated, yeah? And also, as Natalia mentioned before, is also about the law. So there is the GDPR that came into force earlier this year, which means is about protecting private people data. So if companies leak data, they can be fined by, I think, 4% of the gross worldwide income, something like this. It's gigantic amounts of money, but also people may end up in jail as well. Okay, so there is a level of personal responsibility. There are regulations about NIS regulation that is about making businesses that offer services online more secure. This is in the UK. So the law is catching up, yeah?
And nowadays, it is such a big thing, security, that even newspapers highlighting it, they have even separate sections for security breaches. And if you think that it is not happening that often, let me show you 10, the biggest leaks from 2019 to 2018. It's just extortion numbers, 1 billion records breached. And it's just 10 the highest ones. If you're interested in overall amount of breaches, let me show you this website. And according to this website, since 2013, there was 40 billion, more than 40 billion records stolen. And if you can have a look, there is only 4 of them have been 4%. Encrypted. 4% was encrypted. So 96 were unencrypted and useful, and only 4 of them have been useless. And it gives us that every second, there were 74 records stolen. That's quite a big number, in my opinion. So, can security be retrofitted? Well, not really. And you may think, okay, I will create my application, I will polish it, make it nice, fast, and then I will think about the security. I will test it, all going to be fine. Unfortunately, it doesn't work like this. It is not that easy. Sometimes the problem even in the architectural decision, and it's very hard to retrofit the architecture. And as well, it is very expensive. If you can have a look on the graph, further it is in the development, more expensive it is to fix the security defect. You don't really want to be at the end and pay a fortune. And it is because security is not a feature. You can't just implement it. It's system quality.
Yeah, so we say, okay, it's a system quality, so as, or some people prefer to call it a non-functional requirement, if you like. I don't like the word because non-functional means it doesn't function, which in most cases is an accurate description of security in many systems. So let's say that you are actually starting from scratch, yeah? So first of all, if you are starting on if you have the luxury of working on a greenfield system, and we can think about these things from the beginning, the very first thing to think about from a security perspective is we are not aiming at 100% security. This is not a reasonable goal, okay? Because we are not going to achieve it. So what do we need to do then? So, well, a system is actually considered to be secure when the cost of hacking is higher than the value of data. So cost of hacking here, we are not talking simply about money, okay? If it is a hacker in the bedroom, yeah, trying to hack the system, is how long does it take for this person to become bored, yeah? If it takes, you know, a long time because it's very patient, maybe you have to be a bit more secure. If it is less, you can make a lesser effort, if you like. So it's not simply about money, it's about the cost from a hacker perspective, okay? And then, okay, as we said, you need to start early, from the very beginning, and start, for example, when writing your user story. So how many of you work in agile kind of teams? So most people here probably use user stories, epics, stuff like this, yeah? Am I correct, for your requirements? So you can start exactly at that point, yeah? So when you think about your requirements, you can start thinking about what are the security implications of this particular functionality, yeah? And then how should we start? So it's like where, but now how? Something that you should consider is threat modeling, which is a risk assessment of the application. We'll give you an example of that, yeah? And what you can do with threat modeling, you can actually do this for each story in your backlog, for each requirement you have. Yeah, of course, we said that being a systemic also concern, also when you think about architecture, it's not simply about the backlog, there is also about how you are going to do your design, so you can support some of it, yeah. And then, when we start, also we need some definitions. So first of all, what is a threat? A threat is actually what an adversary might try to do to the system, yeah? So it's a goal. And then there is a concept of vulnerability. Vulnerability is a flaw in the system that will allow the hacker to achieve its goal, basically to realize the threat, yeah? And some things you need to understand as well. You need to know what you are building. We said this from an architectural perspective. And here there is this graphics to illustrate some concepts. There is a concept of entry points that is anything you can do to interact with your system. So it could be, let's say this is the system, this is some external connect, it could be APIs to connect to the system. But an entry point is also potentially, can somebody get into the computer room and log in into the box where the system is running, for example, yeah? The database connection could be an entry point. If the database is, if the connection is unencrypted and this is available within the network of your organization, is potentially an entry point for internal threats, yeah? There is a concept of trust levels, basically what you do to authenticate and authorize people or systems that use your system. So here, for example, there will be maybe some authentication of client and then allow them to do something. There is a concept of assets that is basically, sorry, sometimes I move and the voice goes up and down. Oh, that is what you are protecting. Assets could be data. Usually in movies we see that the assets are data, but sometimes it's the system itself. Imagine a system that is used by emergency services that has to be up and running because when you call, I don't know what is 999, they have to provide you the service. If the system is not running, is made unavailable by a denial of service attack, they cannot actually send the ambulance and people may die, okay? So that is a security aspect as well. So the system itself may be your asset. And there is a concept of trust boundaries that is basically when you move from a place to another. So this is within the trust boundary of the system. That side is trust boundary of that one, if you want. This is where the border of security is, okay? So when you go from here to here, is going beyond the trust boundary. And then there is the attack surface. This can be literally anything that will allow you to get data to and interact with the system, okay? So if you can FTP to the machine with some admin rights and do something to service, that is part of the attack surface. So the attack surface is not simply the external APIs or your REST calls or anything like this, is any entry point you have, and is anything you can do that will allow you to interact with your system and potentially wreak havoc. Does it make sense? Yeah, so when you think about security from this aspect, you have to think about lots of things here, okay? It's not simply, is my REST API with good authentication and my roles work well and stuff like this. There is much more to that. You have to think at the system level, take a step back and think in terms of what should I do to actually wreak havoc here, to steal data or to shut down the system or to make it unavailable, yeah?
And then once you know where exactly can be potential risks and what exactly you're protecting, you need to think what type of an attack can be applied to those assets. And in this case, you can use classification of threats. In this example, we will use Stride, just because it is one of the most known and common to use, but you can use any of them. It's basically when you see from the perspective of attacker what can happen. So, Stride. It goes for spoofing. So basically spoofing, it's when a person misrepresents himself in order to listen your data. It's basically man-in-the-middle attack. Quite good example, quite common example. In the Second World War, hackers tried to listen communication when they trying to break Enigma and have been listening communication of Germans. Tampering, it's basically when a malicious person, changing the data, and this influencing the second part. About a couple of years ago, Russia was blamed for influencing US election. So this is kind of an example of a tampering when the data is changed, so the result is different and it's quite valuable. Repudiation. A good example is when a person tries to send money in the bank account and then say, it's not me. So you basically need to prove the actions of a person. Information disclosure. When information is given to a person that's not supposed to be for him. As well, a good example in the films when a hacker gets into the system and gets information from a secure organization.
Yeah, it's like stealing information that is supposed to be secret. You know, it's the typical thing from the movies, this one.
Yes. Denial of service. As Giovanni have been saying before, you need to think as well about the asset as a system itself. Because in some cases, the system itself is very important. And think about your system, what happens when someone is getting to your server room and switch the power, or when the penetration testing tool firing too many requests to your system and used maliciously in order to put your system down. What's going to happen? Elevation of privileges. As well, a good example from the movies, when someone is getting as a root access and do bad stuff, it's basically when a malicious person is given more rights than he's supposed to have. And once you know what type of attack can happen, you can see the combination, because it's not just one specific threat is applied to your system. There can be a combination of different. For example, in this example, let's take outbound data flow to a process. It can have a spoofing attack, it can have a repudiation attack, it can have an information disclosure, denial of service, evaluation of privileges, so many of them combined. And you need to think what exactly can happen and how you're supposed to protect against them.
And when you know about these classifications, another thing to keep in mind is that it's just a way for you to analyze the vulnerabilities of your system. It's not that an attacker will say, okay, I'll just try a tampering. What hackers do use a mix of this, yeah? So I try to access a system with an elevation of privilege, okay, trying to become root somewhere, and then now that I'm root, I'll go for the information disclosure. That is basically my goal is to steal data, okay? So the classification is useful from a point of view of mitigating or eliminating vulnerabilities, but it's not about what the hacker is going to do, because they are going to actually perform several of these actions to achieve their goal, yeah?
And you can play a little bit as an attacker, so you can represent the actions of what can happen as a tree. In this example, we took a login to a user account, and we have a tree, which is an OR tree, and any path here can lead to the fulfilling of the goal.
Yeah. This is basically an example of a threat model. It can be as simple as that, okay?
Yeah. For example, malicious person needs to log into your account. He knows the username and he needs a password. How he can get the password? Well, he can guess a password, which is quite complicated, but he can call you and start saying like, oh, you have a car accident, please give me some of your details. And basing on that, he can think about some passwords, because lots of people put their names and the name of the cat or something in the password.
Date of birth. Or
date of birth, exactly.
Personal information is often used for that.
Yeah.
Yeah.
Or actual programmatic phishing. Quite recently, I had an email saying, in your iTunes, you have an invoice of £150 with a lots of weird purchases. And in order to verify it, please log in this website and put your credentials. And basically, when you go there, if you put your credentials, you're hacked. Or, for example, a programmatic steal, when you can be hacked through the database with the SQL injection. And once you thought about different possible scenarios, you can think how you can defend against that. For example, against SQL injection, you can do a validation. It is, quite common thing. And then there are harder things to think about, which is a phishing. It's quite hard to defend against a user behavior, because you can't just say, you can't just influence a user, really. However, some companies like banks, they tell you, we're never going to call you or send you an email asking your credentials. So if you get this email or call, don't believe them.
Yeah, I think that the interesting thing about this is that it's a thinking tool, yeah, when you think about your application. And also, this is just as an example. So when you have a threat model, so when you think about your functionality or system modeling a threat and to decide what to do to mitigate that, you need to document it. Now, this is just for illustrational purposes. This is a free tool from Microsoft that they created exactly for this purpose, to document threat models. But actually, it's not mandatory to use a specific format. There isn't a specific format. The format in the document is whatever works for you. Yeah, could be a Word document, could be some notes in your user story, if there are any security-sensitive things you should consider. Could be anything that will basically allow you to think about what you want to do to keep security high in your system. Yeah? And then there are aspects, I think in the keynote today, Professor Sasse actually mentioned them very well, in terms of usability. Yeah? So how many of you have worked in stories that were written like this? As a user, I want to log in. Yeah? Now, no, I don't. I'm a user, I don't want to log in. Okay, so this functionality is not there because I want to. Okay, I've got another goal. I have to log in, yeah, to actually achieve my goals. Yeah, this is just to make a point that there could be some functionality specifically there for security purposes. So anything that is related basically to authentication of users is in this class. Yeah, it adds friction. Yeah, so the user don't really want that, but is a necessary evil, if you like. Yeah, they have to do that, otherwise the risk is to lose security. Of course, there are some mitigations. You know, for example, sometimes if you use the modern iPhone, they do face recognition. And so for a user, it's like easier. You know, you look at the phone, unlocks, and you can do your thing. We'll talk later about why this is not necessarily the best security, but why it's good enough, yeah, when we talk about trade-offs. Okay? So when you think about the system, never go with, as a user, I want to log in. Anything related to authentication security is more kind of, perhaps you want to, as a user, I have to log in, but what I might prefer way is expressing that in terms of what the system should provide, yeah, to make security actually work correctly. In my view, that will put you in a wrong mindset, yeah.
And for the user, security can be tedious. The constantly logging to the system can be very annoying, especially when you log off if you just switch the application. However, the user wouldn't be interested in leaking his data, right? So the security comes with the price, and you need to think how much the user can pay for it, basically how much effort he's willing to do before he will leave the application. And here comes the trade-offs. So you need to balance. A good example of the trade-off is a two banking app. One of them is Barclays, one of them is Monzo. As a default behavior on the Apple phones, Barclays asks you to authenticate each time you entering the application. So anytime if you switch between bookmarks in the phone or log off the application, when you come back, you have to log in. This is very secure because nobody can see your data, even how much money you have. And if you have like millions, nobody knows about that. However, it's quite annoying, especially if you just want to see your transactions and try to compare or something like this. Each time you have to put your password in. However, on another side, there is a Monzo application which gives you information about your balance and all your spendings without authentication as a default behavior. However, when you try to transfer money or do something with your money, it asks for an authentication. It's less secure, however, it's much more comfortable for a user. And it's up to the user already to think if he cares about that someone sees the money when the phone is opened on unlocked on the table and someone can take it and see how rich or poor you are or not. Another good example is Amazon. Basically the example on no reputation. Because when you're ordering something from the Amazon and it delivered to you, you can just say, it hasn't been delivered, call to Amazon, and they're not going to check. Because it takes more time to verify where it has been delivered, who has got it, and so on. They just send you the parcel. So they just don't care, because how many people do this, right?
Yeah, and actually I've got a good example of this now that I think of it. When there was the Black Friday sales, we bought a microwave. According to some point, the delivery was delivered to our neighbor, and they had also a signature there, but we never received it. The neighbor, when we went there, Amazon told us that, no, we haven't received anything. So we contacted Amazon, and without any fuss, what they did was refunding the money. Okay, so they even if there was, signature, somebody has faked a signature somewhere, they didn't bother checking the reputation there because it could have been more expensive to do that. Okay, so it's again a trade-off. They decided not to spend too much time on that because it was much less convenient than say, okay, we refund your money, and maybe your chances are you are right, so you'll be a happy customer for the future. Yeah.
So it means don't go for implementing all defenses that come into your head, just because it doesn't worth it. And you need to have a plan what to do next. So start from low effort and high impact. It can be just hashing your passwords in a database, right? It is quite easy to do. However, it gives you quite high value in case your database is stolen. It's much harder to guess passwords. And then go to high effort and high impact, which can bring you as well a lot of input, but takes more time or more money. For example, penetration testing, which requires more skills, more money, and probably more time. However, it is very valuable. You will find the bugs in your systems. And after that, you can go to low effort and low impact if you have time and you really think you can do it. It won't be really bring much value, but yeah, it's not a very high effort as well. For example, editing extra hashing cycle or salt or something like this. And never go to high effort and low impact just because it doesn't worth your time unless there is a specific reason for that, like legal requirement. I know that if you're a government organization, you really need to use their encryption algorithms. It doesn't really improve your security much, and it probably takes more time to change your system. However, otherwise you won't be able to work with the government. Yeah, basically you may have some requirements to do that, so that they don't really bring value in terms of a better secure system, but you just have to do that. Yeah. Okay, because otherwise maybe it's, as she said, a government organization, and if you don't do that, you don't get their business. Okay. Another thing we need to add is that is not a static diagram. So things that can be at some point low effort, low impact, at some point can become actually high impact. This happens when, for example, a system is quite new, okay? You have the new system is used by maybe 100 or 1,000 users at the beginning, so not very high load, and there are some things, some vulnerabilities that could be exploited, but the chances of them to be exploited is very low, simply because there isn't that much use of the system. Then you scale up to 1 million users, that problem changes completely. Because now the chances of the vulnerabilities to be exploited become much, much higher. So at that point, you may actually want to say, okay, now, you know what, we didn't do this before, we want to do this now, okay? So again, there is a level there of judging when to do something. It's trade-offs, cost, benefit, yeah? So, what is definitely needed? Start from low effort and high impact things. Use communication encrypted channels. I hope you're already doing it, but just in case. And yeah, if you're using REST, use HTTPS. It's quite easy right now. Hash your passwords, as I already mentioned, as well as quite easy and brings you quite a lot of effort. Effect. Yeah, and then encrypt sensitive data. You may have data in your database that is truly sensitive. You may want to encrypt that. Yeah, and again, the algorithms are there. You don't necessarily need to do a lot of work for this, and the benefits could be quite high. Yeah. And
don't log security sensitive data, no passwords, no usernames or account information or tokens or anything like this. Now, one comment about this slide is that all this stuff should be obvious. I hope it is obvious for people in this room. However, it's not really obvious to most people out there, okay? We work together in an authentication system in a leading retail bank, which could be any bank because all of them lead somewhere, or so they say. Logs in the authentication system with usernames, passwords, shit like this. Sorry for the wording. But when I actually told people, why are we doing this? This shouldn't be there. The response, oh, we cannot touch this. We need this for testing. So there was this strange attitude that can be extremely dangerous. Yeah. Also because there was the assumption that internal threats don't exist. Everybody within the bank is good. The bad people are outside. This can be a very dangerous attitude to have, and there is no need to do that, okay? And the other aspect is production credentials or anything that goes in a production system. Don't put them in your Git repository. You're laughing. Same big bank. They had a publicly visible repository that was hacked. And there were some production things that shouldn't be there. Unfortunately, we are not for systems that were really deployed, but this scared them quite a bit. And so they went, okay, now all the teams check your Git repositories. We don't want any production, anything. You have to fix this by Friday. This was on a Monday. Funnily enough, the answer was, unfortunately, we cannot really do this because then we cannot deploy anything at all for quite some time. And this, unfortunately, was also in our authentication system. Okay, so it's not that we did the whole thing ourselves. We found that there. Okay, this is extremely dangerous stuff. Yeah. And if you consider this, if you think about these problems from the very beginning, there are many, many ways to just avoid having the problem altogether. Yeah, but when you have it, at some point they fix it later. Also, this is a security aspect that can have a big cost for fixing. Yeah. And validate the inputs. Again, should be obvious. Yeah. This is about SQL injection. A school that comes, a mom and say that there's some school that calls and say, oh dear, did he break something? And did you really name your son Robert? Quote, bracket, semicolon, drop table, student, semicolon, minus, minus. Oh yes, little Bobby Tables, we call him. Yeah? And they say, well, we've lost this year's students' records. I hope you are happy. And I hope you've learned to sanitize your database inputs. Now, again, this should be, again, something that should be obvious. How many developers that actually, when they create SQL queries from input data, sanitize the data first or normalize it? Yeah, I often see string concatenations just to create a SQL. That is open to SQL injection attacks. Yeah, partly sometimes if you use Java and use JDBCs, the interface itself can be quite clunky to sanitize the data. Lots of set, get, calls, stuff, lots of noise there. Yeah, but unfortunately, if you don't do that, you really can be exposed to serious risks without even noticing that. Yeah. So, and again, this is something that can be avoided quite easily.
So I hope you already use HTTPS in your production. If no, let me show you one tool, which is called Pineapple. It looks like a router and acts like a router, serving you the internet from another source and scanning your SSIDs on the laptop and the phone. And because your device have already previously connected and trusted, he can automatically connect again. And this tool can see all your unencrypted communications in a clear text.
Yeah, basically it does a spoofing of the network ID. Yeah?
Yes, exactly. And please don't use self-site certificate in production, because this tool can grant you a self-site certificate. And if you are as well for usability and accepting everything that's popping up in your web page, this tool gonna see you on even encrypted communication, basically acting as a man in the middle
Yeah, because with self-signed certificates, you must have seen them. Usually what happens is the application recognizes that it's self-signed, maybe your web browser, and it tells you, look, it's self-signed, are you sure you want to do this? Or if you open Chrome, it says, the strange page say, this is not secure, you should be careful. But often we go away, just do that. And then you have a problem. So if you do that in your production system, it's like, I cannot be bothered with the proper certificates. I self-signed that. What you are doing, you are exposing your users to serious attacks. Yeah.
And as well, use certificates in tests, because you really need to think how you're going to manage certificate later in a production, and you don't really want to appear at one day, all certificates are expired and you need to change them, and you haven't thought about it just because all your tests were with self-signed certificates or HTTP.
Yeah, it's a typical thing which we have seen again and again with, applications using REST. The programmers often have the HTTP version for testing purposes because it's simpler, and the HTTPS for production. There are many problems with that. One of them is also that if you don't use HTTPS at all times, you don't even think from the beginning on how to manage the certificates themselves. Then, as Natalia said, you end up with managing them manually, and then they expire at random times, and your application is not available anymore, and you have lots of problems. If you always if you avoid HTTP completely, you actually design your system such that you are able to manage the certificates, because you need them in your local tests, you'll need them in your continuous integration or in continuous deployment or delivery as well. And so you'll start thinking about the problem on how to do that early on.
Yeah.
Yeah.
As we said, early you start, cheaper it will be for you. And then it is not hard. There is such a community as Let's Encrypt, which gives you certificates for free and even help you with automating the renewal of the certificates. So if you're concerned about the cost, go there. And some people says that security can downgrade the speed. And in testing, let's say we want to be really fast, so we're going to use HTTP. And it's not really the case, because HTTPS is actually faster. And if you don't believe us, go to this website and check. They are showing it actually in action. And it is because the HTTPS has actually another system underneath, another protocol, basically.
Yeah, it's not the same as HTTP with an S at the end, some kind of hack HTTP as it is and make it secure. It's a completely different protocol. Yeah? And so it's actually much faster here. I don't know if you can read it from there, but it's basically 9 times faster than HTTP. So this in itself, speed is not an excuse there even for testing, okay? And then there are some aspects if you use REST. We are talking a lot about REST because it's quite common nowadays. So GET requests can be a problem. Now, the problem is not the URL. One thing that I should say that since, strangely, many developers don't realize this, that when you send a request to a website using HTTPS, the URL itself is encrypted along with everything else. The only thing that is not encrypted is basically the computer name, where you are sending to, the host you are calling, okay? Everything else, including the URL, is encrypted, the entire message. So it's not the encryption of the URL the problem. The problem is that many web servers tend to log the URLs of your requests in clear text, in their logs. So if you in the GET request in the URL, you put any sensitive data, that may end up in clear text in your logs, exposing the system to internal attackers, okay? And then, of course, there are other aspects where if you put sensitive data in the URL and it's a situation where somebody is working in a room where somebody else can have a look at the screen, they can spot passwords or, can see the sensitive data. It's basically the reason why when you write the password, you only see the dots. Yeah, it's to avoid these kind of problems, okay? And
it's not just about the software it is. It's about the environment that you are working in as well. We have been working in a bank, as we mentioned before, and there are lots of people on the floor, and you can't possibly know everyone in face. Someone entering, someone not. So you can trust that your system going to be secured if you leave your laptop opened. So log off your laptops. And there is a story in our company. We have a security expert that trusted us really seriously, and he went on the coffee break and left his laptop unlocked. And when he came, all his images were Nicolas Cage.
So any Google query would return images of Nicolas Cage in his laptop.
No matter what you're searching.
So
it's just a harmless plugin, just for fun, but he doesn't trust us anymore. But think if it would be some scripts, malicious scripts. I don't know. There are so many tools nowadays.
Yeah. So you need to think about these aspects as well. So it's not only about the software you write, it's about where you are going to deploy it, how you are going to deploy it, and the context of use. You have to look at the system itself. Yeah?
Yeah. Because you need to know how it's going to be used. If someone going to sit behind the person and see the password type, that's why it is not shown in a clear text when you type it in.
Yeah, it's a system level concern. Okay, so your software, you can have all the strongest authentication models or interesting things in your software. However, if it is deployed in a way that is not secure, in a place that is not secure, you have to remember that can expose the system to attack. So you really need to think in these terms. Another example I can give you, think about, an example that we can use is availability. Yeah? Let's say that you don't have an in-house computer room and you deploy on the cloud, Amazon. Yeah? And your system is a system that for security purposes has to be highly available. Yeah? Now you say, we are secure, we are on the cloud. Now, the thing you should think about is, let's say that you trust Amazon for the data centers with the access there and all this stuff. But Amazon sometimes is subject to denial of service attacks. Okay, so a single data center can be brought down. So if availability is a security concern, what you need to do is design a system that you can actually deploy in several data centers far away from each other, yeah, that rely on different subnets. So if there is an attack on one of them, the system goes down there, the other can take over. Okay, so you need to think in these terms. Yeah? And this has nothing to do with the specific functionality, everything to do with the way you actually are able to deploy your system. Yeah? So threat modeling. So when the example we gave before, you think about the problem and look at it and decide what to do. Is it good? It definitely is good. So it's basically a way for you to think about from an attacker perspective. Okay, so it doesn't. If you start early, it will help you create a more secure system. It doesn't guarantee that you are going to make the system absolutely secure, but you will be in a much better position than if you didn't. Okay, because at least you thought about something, you took some action. Yeah?
So are there any disadvantages? As Giovanni said, there are some. So you may miss some weaknesses because we're all human and you just can miss something. And the good threaded modeling session doesn't give you a good software. It can be just written in a bad way.
Yeah, in fact, this quote from Peter Newman, complex systems break in complex ways, basically means you can have a good threat modeling session, you try to protect your system from vulnerabilities, but if your code sucks, yeah, it's complicated for no reason and it's just badly implemented, you still have a problem. Okay, and you might be actually introducing vulnerabilities without realizing them simply because it's complicated. Okay.
So In order to avoid security breaches somehow, you need to start early on, start from the very beginning, and make it a part of your development. And a good way to make it a part of your development is to put it in a definition of done. So basically, without thinking about the security aspects, you won't be able to deliver the feature. And software itself can have vulnerabilities. It's more than just a threat modeling session. You can use vulnerable libraries or something like this. And catch security flaws before something else is built on top. It is much easier and much cheaper. You don't have to rebuild the whole system afterwards. And do code inspection regularly, the same, in order to catch it early on. And have a security champion. As our keynote have mentioned today, that security champion is good to have, and it's not a security expert that know everything and have a certification in security. It's just a person who actually raise an awareness among the team about the security aspects and constantly asking questions. If it is secure, what we can make to do to make it better. And what about to start from yourself, start and be your own security champion. And probably even better thing is to have the whole team.
Yeah, I have to say this is an interesting thing, because since I started to be more interested in security, any system I'm involved with, I actually ask security-related questions. You know, one of my first questions, like in any bids we do for customer internally, one of the first questions is are there any security issues? Like, have we got sensitive data anywhere? What kind of data have we got? You know, what has to be the availability? Simply asking the questions raise awareness. And it's funny how people generally don't think about that, yeah? So if you just have this in your head and start asking the questions, you may actually prompt people to tell you what they need, yeah, what is truly important. It's not a difficult thing to do. It can be extremely useful, yeah. And also, you know, when you write user stories, do you have acceptance criteria for user stories? Raise your hand if you have in your user stories acceptance criteria. Okay, so before I saw most people use user stories, just 3 or 4 have acceptance criteria. Okay, so now what I suggest is when you go back, look again at your user stories and think again, because acceptance criteria is the way you decide you are done with implementing some functionality. And if you have them, you can actually think about how to add to those the security aspects. Sometimes could be some automated testing, some particular scan of the software, things like this, but could be also, look, with this particular API, there is a chance of some external hackers trying to get in, so maybe as part of the acceptance criteria, there'll be some penetration testing to make sure that the functionality is secure. Yeah? Is it moving? Yeah.
And you may think it is boring always to check your system, and then you implemented the feature and test it, and think about it. Well, if you do everything manually, yes. So automated, there are quite a lot of tools, and some of them you have to pay, but quite a lot of them are for free. They're helping you to check your dependencies, check your code, and see vulnerabilities. You can have reports out of them, which is quite useful.
And also some of them can actually break your build if some vulnerabilities, particularly bad vulnerabilities, are found. So they can be part of your build pipeline as well.
Yes.
Yeah.
So yeah, you can put it in your build pipeline. Quite a lot of them have APIs, and you can have it a part of your pipeline and have a report after each build. And yes, it can break your build, so be careful, but it is just the nature of security testing.
Yeah, so again, we said when you check security, there are some things you want to look at. So there are dependencies of dependencies. These are situations where you depend on a specific library, okay, an external library, and this library actually depends on another one that is vulnerable. the tools can actually help you detect that, and that can be important because you need to understand if the other dependency may have an influence on your code base as well, okay? So one level of indirection could be an important thing to check there, yeah? There are ways to check about common vulnerabilities, so there is the Mitre website there, when you can see common vulnerabilities and exposures. Something we strongly suggest is do not implement security libraries yourself. Yeah.
Because it's quite complicated, and there are teams who are testing it and really knows what they're doing. And it's quite easy to make a mistake, especially if it is algorithm-based.
Yes. So especially if it is anything to do with encryption, decryption, they can be extremely complicated. And there is plenty of libraries available there that are actually widely used and tested and are much better than in-house software, yeah? And so use those trusted libraries instead. And then also with Docker, you can check Docker Hub. So if you use Docker images, in Docker Hub they do security scans of the images and can tell you where the vulnerabilities are. Now, the goal there is not to find the image that is fully green, no vulnerabilities. That would be not a sensible goal to have. The goal there is understand if the images you are choosing are actually secure for your purposes. There might be vulnerabilities you are not interested in because you are not exposed to them. Okay, so again, it's not about 100%, it's about sufficient security for your purposes. Yeah. And then retrofitting security. So as we said, this is not ideal, yeah, because it can be really complicated and some systems can be actually impossible. But you can use reporting tools like SonarQube to do some scans in what you've got, yeah? But then the way you use those is, first of all, you don't put quality gates saying, okay, now you scan the system. If there are any security breaches, just break the build. Because you've got a system that is not secure to start with. If you do that, you may end up 2 years trying to fix the system and without deploying anything, yeah? So what you want is find what the risks are, yeah? Prioritize them, and deal with the critical ones first, yeah? So your system will be insecure for a bit longer, but at least a bit more secure each time, yeah? And also, what you want is, of course, log the bugs you find in stories or basically in bugs in Jira, whatever tool you use, and address them. When you fix a bug, write a test for it if you can, yeah? Usually you can, so you know that it's not going to happen again, and you can make it part of your integration testing. And another thing you can do is when you fix those issues, you can actually make sure that the next time SonarQube finds the same issue, SonarQube will break your build, SonarQube or whatever other tool you use. So basically, you raise the bar bit by bit. Yeah? As you keep fixing the problems, you keep raising the bar so they won't happen again. Yeah? One thing to keep in mind is that because of the nature of security, you may have a situation where your build works, then you upgrade your security scan tools to some new version where there are new vulnerabilities. So a build that used to actually work before start not to work again. It start not to work anymore, simply because it was vulnerable to those particular issues, but before they were simply not found because the tool was not supporting them, okay? So this may happen, and it's a normal thing. It is just because of the way security works. So when you update your versions of any tool you use, you have to do that in a planned manner to avoid blocking your development activities, yeah? But in any case, if you started early, you will probably be in a quite good position to take care of those problems very quickly.
So, and as a complementary tool, you can use a penetration testing. It's basically not a vulnerability scan. It is actually a way how to break your system, because anyone in this room now can do vulnerability check by using the tools that we have shown before. So it's not just that. And penetration testing requires skill, and it has a specific goal to get into your system and to find vulnerabilities that you didn't know before.
Yeah, it's basically not about checking vulnerabilities you know about. It's about finding new ones you don't know about. Okay, so the penetration testing will find vulnerabilities in your system, and then you can decide how to address them. Yeah.
Yeah, it's basically ethical hacking in a way. So, summing up,
You're quite early.
No system is 100% secure. We're not aiming for 100% security, just because system is already considered to be secure if the cost of hacking is higher than the data that can be gathered. And think about the potential risks. Play as a hacker who wants to get to your system and think what can possibly go wrong with it. And thinking about the security won't guarantee you that you catch every issue, but you will get in a much better position.
Yeah, and as we said before, the way to act is basically starting from what gives you the highest benefit versus cost. So high impact, low cost first. So as we said, hashing passwords, maybe using encrypted communication, things that are available there. Second, high impact and maybe higher effort, so like penetration testing that requires specialized skills and costs much more and has more effort. Then we have the low impact, low effort. You may or may not want to bother with them. Yeah, because if you have time, you address them. Otherwise, the impact is low, so you don't spend your time if you have higher priority things. High impact, high effort. Low impact, high effort only if you must, because of some specific requirement, like could be regulatory requirement, laws, or maybe a system for government that they really are keen on their own specific algorithms or something like this. Yeah. Yeah.
So make it a part of your development because it's easier to catch bugs on the way rather than to fix them at the end. Because the security is not a feature, you can't just implement it at the end, it is a system quality. And think about the security as a whole. Think about your system, how it's going to be deployed, who is going to have an access to deploy it. Is it going to be one person? Do you need a second verification of it? Where it's going to be deployed? What can happen if it goes down? And think about how it's going to be used. Who is going to have access to the application as a user? And what the user needs to do in order to be authenticated. Think about it as a whole. And it's not just about your software. As I said before, it's about the system itself. Thank you.
Yeah.
Any questions?